And those who gave the last on that day, I will also give you the marks. Okay, I'll also give you the marks on that day. And what else? What else? Yeah, nothing else. One more thing. So the next class that will be on Wednesday night will be of 2 hours. So on Wednesday, the class will be 1.5 hours will be lecture plus 30 minutes will be test. Is that clear, everyone? Yes or no? Please tell me. Abdul Rahman, Abia. Okay, Avril also joined. Avril has not connected to the audio, but ha guys, clear now? Yes, Muhammad Sahel, Fahad.
Yes, sir.
Okay, fine. What happened to Avril? Okay, Abia. Okay, fine. Now, in the last lecture, we saw that there are two things which happen in a nucleophilic substitution reaction. The first thing is that cleavage of or breaking of which bond? CX bond, in which X is the leaving group. The second thing that happens is what it is the formation of carbon nucleophile bond. Now, please don't write now. Okay. Now, these two steps, it can happen in individual steps or it can happen simultaneously. On that basis, what we can do, I can say that the types of Sn are two. I can say that Sn can be of two types. In one of the case, Sn can happen in 2 steps, Sn in 2 steps. And the other case, I can write Sn in 1 step. Okay, please don't write this. I'm just explaining this. Sn in 1 step. Okay. Now, Sn in 2 step, in that what will happen? The first step will be the carbon halogen bond. It will break, and since halogen is more electronegative, electron will be shifted towards the halogen atom. And when these bond will break, you will get carbon positive and X negative. Okay. The second step will be this carbon positive. It will be attacked by the nucleophile. The nucleophile obviously will have one lone pair. So this is electron source. Here we have a higher density of electron and C positive. Positive means we have an electron deficient or an electron poor side. So this nucleophile will attack on this carbon and you will get a carbon nucleophile bond. Get a carbon nucleophile bond. These two steps here, it is happening in what? It is happening in 2 different steps. Now, if Sn happens in 1 step, then what will be happening? There will be a nucleophile plus there will be a CX bond, something like this. And this nucleophile will have some lone pair. And due to the electronegativity difference, there will be a delta negative charge in the halogen atom and delta positive charge in the carbon atom. So again, the carbon here is also, it is what? It is electron deficient. And the nucleophile will easily attack on this carbon atom. And as soon as the nucleophile is attacking this carbon atom, what will happen? The electron density will shift towards X and X will leave as a leaving group. So you will get a bond something like this, nucleophile carbon plus X negative. So there are 2 ways in which Sn can happen. Logically speaking, if you have 2 steps, that means there can be a reaction in which the 2 steps are having in individual steps, and there can be a reaction in which it is happening simultaneously. Okay. So if I look at this particular reaction, now all of you will answer. Okay, all of you will answer me. If I talk about the probability of reaction, that means the nucleophile should be hitting the substrate, right? This is my nucleophile and this is my substrate, that is the haloalkane. So nucleophile must be hitting the substrate. So what do you think? The reaction will be faster when concentration of nucleophile and CX is higher. Tell me, what do you think? If nucleophile and the haloalkane are in greater amounts, they have a high concentration, then the probability of colliding will be higher. Yes or no? Tell me, the probability of colliding will be higher or lower? What do you guys think? Probability of Abia, tell me.
Yes.
Right. So if the concentration is higher, probability of collision will be higher, and if they are colliding more frequently, then the product formation will be also faster. Yes or no? All of you agree with this? Okay, Adriel. What about others? Tell me. If the concentration is higher, probability of collision is higher. That means nucleophile will be attacking the haloalkene a much more easily and a faster rate, and the product will be formed easier. And that is why here we say that the rate of reaction, it depends on two things. It depends on the concentration of nucleophile as well as the concentration of is equal to, rather I should say it is proportional to the concentration of nucleophile and also the concentration of Rx. Okay, also the concentration of Rx. But if I look at here, now I have to see which of the step here is which of the steps. Now, if I look at the first step and second step, what do you think which is more difficult? To break a bond or to form a bond? Abdurrahman, tell me. What is more difficult, to break a bond or to form a bond?
Sir, to break.
Yes, Abdurrahman. To break. Abia, what do you think? To break or to form?
So can you repeat a bit?
What is more difficult? What is more tough, I can say also? To break a bond or to form a bond? Tell me.
Break.
Break. All of you will agree, yes or no? Please write yes or no in the chat. Those who can't speak, Fahad, Sahel, Adriel. Break or form, which is more difficult? Yeah, okay. Now, if this first step is more difficult, that means it is going to be slower than the second step. Is that right? Yes or no? Please tell me. Correct? Hai? Now, then I want to ask you guys a question. Please look at this question. I hope you guys are not writing anything. Okay, please don't write. You will write each and every part. Don't worry about that. If I have three things, let us say I have a t-shirt, I have a shirt, and I have a jeans. T-shirt takes 5 minutes, shirt takes 10 minutes, and jeans take 15 minutes to dry. Okay, this is to dry. So in total, tell me if I want to dry all of these three, how much time will it take? Sahel, are you back at home? Yes, Sahel?
Almost, sir, almost.
When you get home, then we can discuss that, okay?
Sure, sir.
Okay. So in total, if I want to dry it, how much time will be taken? Abia and all of you, please answer in chat. I have three things. How much time will it take to dry these three? Adil, I got yours. Fahad also, I got yours. Waiting for Abdurrahman, Abia, and Muhammad Sahel. It takes 5 minutes to dry a t-shirt, 10 minutes to dry a shirt, and 15 minutes to dry a jeans. So in total, if I want to dry all of these three, how much time will be taken? Okay, Abdurrahman. Abia, I'm not getting your answer. Send it to Salim. Okay, fine. So there are conflicting answers. Now, those who have answered 30 minutes, please think again. You have kept the t-shirt on a rope or something, shirt on a rope or something, jeans on a rope or something, right? So in total, it will take only 15 minutes. By the time this jeans is dry, the shirt and t-shirt will be already dry. So you will not take what, 30 minutes. Is that right? Yes or no? Abdurrahman, Abia, and Fahad. Clear? Eh? Yes, na? Okay, fine. So what is the step which is determining? What is the step that is determining the fastness of reaction, or the rate of this particular dryness? The slowest step. It depends on what? It depends on slowest. How fast your reaction is going to happen, or the time it is going to take. It depends on what? The slowest step. That is why the slowest step is also known as the rate determining step. Okay. Slowest step is known as the rate determining step. And in this case, which will be the rate determining step? The first step, the formation of carbocation, will be rate determining. And that is why the rate will be directly proportional to only the concentration of CX bond, that is the haloalkane. If the haloalkane is greater, that means the reaction will be faster. Okay, so here rate depends on one molecule, here rate depends on two molecules. So since it depends only on one molecule, it is known as unimolecular unimolecular nucleophilic substitution, and this is known as bimolecular nucleophilic substitution. This is also known as Sn2. This is also known as Sn1. Okay. Sn1 and Sn2, the name comes from here. We start with very simple basic logic. We did not start with Sn1 and Sn2. We also derived how this name came into being, Sn1 and Sn2. We started with a simple logic that Sn can happen in 2 steps or in 1 step. And from there, we proved that there can be 2 different types of nucleophilic substitution, namely Sn1 and Sn2. Now, what you will do, you will write the types of Sn. Okay. आप यहाँ से आप लिखना चालू कीजिए. I hope you have understood each and everything. Now, Sahel, when you get home, please remind me. I will explain you why this is the.
Okay, I'll just start. I'll disconnect.
Can we talk now?
Yeah, I'll disconnect. I'll join from another device and I'll write with you. Is it okay?
Fine. Okay, no problem. Okay. Now, if you write types of Sn. Types of. अभी आपको समझ में आया Sn, please tell me. Yes, Abhiya? You can speak, Abhiya. I am writing. Difficult to always see the chat.
Yes, sir, I got
Abhiya,
it.
okay, fine. Very good. Sn1 and Sn2. Okay. Now, first of all, you will write the topic. Sn1. It refers to unimolecular nucleophilic substitution reaction. With the second point, the reaction in which Rx, and I'm writing it as a reaction, short for reaction. Okay, the reaction in which the rate depends only on the concentration of substrate. Since we are doing a general Sn, writing what general Sn, but in this chapter you will write what you write depends on the concentration of substrate, that is alkyl halide. Okay. Now write the next point, the rate law. In rate law here, R is what? It is equal to K into the concentration of alkyl halide, that is Rx, or also write R is equal to K into the concentration of substrate. Now, the next thing, it is known as order of reaction. So the order is what? It is the sum of the powers of exponential powers of the concentration term, sum of the powers of concentration term. So here Rx is what? It is having a power of 1. So order will be equal to, order is equal to 1, and molecularity, it is also equal to 1 because it is unimolecular. Molecularity is also equal to 1. Okay. Fine. Write this much. Let me know when you are done.
So that is R equals to K, right?
R is equal to K, huh? K into Rx and K into substrate. Order is equal to 1, molecularity is equal to 1. Done everyone? Yes or no, please tell me. Is there anyone who is still writing? Substrate is carbon. Fahad Aziz, can you please turn the mic on?
Yes, sir.
So there are in each and every organic reaction, there will be two things: substrate plus reagent. That will give you some intermediate, and further on, you will get some products. Okay. Substrate is the reactant which has carbon atoms. Okay. So this is the organic molecule. And in this case, the substrate is what? It is alkyl halide or haloalkane. In this chapter, for Sn, it is what? Substrate is haloalkane. You got it? Yes or no? Tell me.
Yes, sir.
Okay, so it is not one carbon, but it is the organic molecule. That means carbon containing. Reagent can be both. It can be organic also, and it can be inorganic also. But it will have, generally reagents these have, they are more polar than the substrate. They are more polar than the substrate. Okay. Fine. Now let us look at the mechanism here. Mechanism. It happens in two steps. First thing, it happens in two steps. The number one step is cleavage of CX bond. You can also call this formation of carbocation. Okay. Sahal, you were saying that formation of bonds takes more energy. Why? How can you explain that?
That's what I'm not sure, sir. Am I right? I'm asking.
No, but you must like. So let us think about it. Then you don't know, right?
Okay, yeah.
Anna. So let us think
Right.
about it. What do you think? When there is a
Uh,
bond, will there be attraction between the electrons and the nuclei? Yes or no, between those two atoms? What happens? Here is carbon atom's nucleus. Here is the halogen atom nucleus, right? This is positive and this is positive. So in general, there should be a repulsion between them. But here are electron clouds. Okay, here are electron clouds like this. Electrons are here. So what will happen? This positive charge will be attracted towards the electron. This positive charge will be attracted towards the electron. And as a result, both of these positive charge are attracted towards each other. Yes or no? Now, in order to break this particular attraction, what we have to do? We have to give energy. Is that right? Yes or no?
right.
Right. If I look at this particular reaction, here we have electron density. Correct? Yes or no? Electron density will be negatively charged. Correct?
Exactly. Yes.
And then there will be a positive charge, that is carbocation. Now, what do you think? This electron, they will
Right.
automatically go to this positive charge. Yes or no? We don't know to do. Do we need to do anything here to make this negative charge to go to positive charge? Tell me.
Energy. I think work should be done, right?
Why? Because they are already attracted. We don't have to do anything.
Okay.
I'm asking, will be giving the energy? There will be energy released whenever there is negative charge and positive charge. Whenever there is attraction, the energy is released. We don't have to give in energy, okay, in the system. So that is why whenever you are breaking a bond, it will be requiring more energy than when you are forming a bond. So you have a carbon atom here. Carbon atom is bonded with 3 different groups, and there is one halogen, which is the leaving group. So what will happen? It will break like this, and you will get a carbon with a positive charge. This is known as carbocation. Plus X negative. Why I have shown here reversible? It is, first of all, it is slow. Okay. Now this X negative is also what? It is also having a high electron density. So this X negative can also attack on this carbon positive, and it can again form the haloalkane. That is why it is slow, reversible, and in this case we use a polar solvent. There is a complete topic on why do we use polar solvent that we'll discuss later. But as of now, please write polar solvent. The next step, what you will write, the formation of CNU bond. Carbon nucleophile bond. It is also known as attack of nucleophile. Attack of nucleophile. Now, in this case, we have the carbocation plus nucleophile with a lone pair. Now, this nucleophile will attack the carbon with a positive charge, and it can easily form carbon nucleophile bond. It can easily form carbon nucleophile bond. So this will be very fast. Done, guys? Yes or no? Please tell me. Done. Okay. So no one is writing. Right, the second one. So we have looked at Sn1. Now we'll write about Sn2. What is Sn2? It refers to what? It refers to bimolecular nucleophilic substitution. Bimolecular nucleophilic substitution reaction. Next point. What happens in Sn2? Sn2 is that type of reaction which depends on both on the concentration of alkyl halide, that is the substrate, as well as the nucleophile. Okay. So the reaction in which rate depends on the concentration of alkyl halide as well as nucleophile. What is the rate law here? R is equal to K into the concentration of substrate, that is alkyl halide, into the concentration of nucleophile. Now, this Rx also has the order 1. This also has order 1. Order is the sum of, what will be the order? Sum of the powers of concentration. It's fully click up. Sum of powers of concentration terms. Just a second. Okay. I'm still getting the ETH calls. Fine. So order is what? Sum of powers of concentration terms. Right. So here the sum of the what is the power 1 and 1. So it will be equal to 2. The molecularity will also be equal to 2 because it is bimolecular reaction. Okay. Write this down fast. Then we'll look at the mechanism. Okay. Is there anyone who's still writing? No. Okay. Right. Next, mechanism. So in this reaction, what happens? The cleavage of CX bond and formation of CNU bond takes place simultaneously. Takes place simultaneously. In this, you will write a reaction. Carbon. Draw now in this draw the bond of X like this, and rather draw the nucleophile here. So nucleophile plus carbon. But this nucleophile can only attack backwards because in front of it has halogen atoms. So it can attack from the backward direction only. Now, as soon as it will attack, what will happen? This X bond will start to cleave. And this will lead to a formation of transition state. What is the transition state? So in a transition state, you'll have carbon atom. Those 3 bonds will be as it is. And then let me make the X bond as dotted red. It means that it is going to break, and the carbon nucleophile bond as dotted blue. It means that it is getting formed X and Nu. Okay. So in this step, what is happening? This is known as the transition step. So you can say that a transformation is happening here, right? It is in between. And as a product, what you will be getting? You'll be getting a nucleophile that is attacked from the that is attached on the opposite side as that of the leaving group, and there will be an X negative. Okay, there will be an X negative. This is known as the transition state. Which X? This X is negative, yeah. Which X you are talking about? In the transition state, Fahad, can you please turn the mic on? Fahad?
Yes, sir.
No. In the transition state, it will be, you can write a delta negative charge here, obviously, but not a pure negative charge because it has some interaction with carbon. So you can write delta negative like this, but not a pure negative charge.
Okay.
Okay. If you want the like perfect stereochemistry here, so one of these bond will be out of the plane and the other bond will be inside the plane, something like this. But we will talk about this stereochemistry part in the later and at the end of the chapter. Okay, stereochemistry. So Everyone's done? Yes or no? Please tell me.
Yes, sir.
Okay. Now write the next point. Factors affecting Sn1 and Sn2. Sn1 and Sn2. There are three factors that we'll be looking at: nature of substrate, secondly, we'll be looking at nature of leaving group, thirdly, we'll be looking at the nature of solvent. So please write the first topic, nature of substrate. Nature of substrate. Okay. So in nature of substrate, you will write the first topic, that is reactivity of Sn1. We're looking at first of all reactivity of Sn1. How the reactivity differs if we change the substrate structure, if we change the structure of substrate. So in Sn1, what is the barrier? There is something which is known as the big barrier. In Sn1, the barrier is carbocation. If we form carbocation, the next step is very easy. So here the reactivity of Sn1, it depends on, please write with me, reactivity of Sn1. It is directly proportional to stability of carbocation, because that is tougher. What is tough to make? Carbocation. But if the carbocation is stable, it will be formed easily, and the next step will be more easy. Next step will be done more easily. Stability of carbocation. Now, if the carbocation is more stable, you can also write as the carbocation is more stable, the rate of Sn1 is faster. Okay, so let us look at the rate of Sn1. So if you have something like CH3x, and you compare this to CH3 CH2x, next you compare this to CH3 CH bonded to one more CH3, further bonded to X, and then you make CH3, which is bonded to carbon. This carbon is bonded to two more CH3s and X. Fine, two more CH3s and X. Now, whenever you want to talk about, or you have to arrange a sequence of molecules in the reactivity towards Sn1, what you will do, you will always draw the carbocation. At least initially, what you will do, you will always draw the carbocation. So what will be the carbocation here? You just remove the X. You just remove the X from all of these. Just remove the X from all of these. What you will be getting? You will be getting CH3, positive charge here. What about here? Please write the molecules and send me on WhatsApp. Draw carbocation, whatever you are going to draw here. Remove the X and add a positive charge. Please remove the X and the bond also. Okay. Don't leave the bond. I see some people writing like this, which is wrong. CH3, CH2, and then they write positive charge like this. This is completely wrong. Don't do this. Remove the bond as well as the X, and then give a positive charge on that carbon atom. Okay. And then you will send a photo on my WhatsApp.
So these are the examples, right?
What?
These are example questions, right?
Example questions. Also remove the X. Okay, Fahad. Also remove the X. As I have drawn here, you can see I have removed the X also and the bond also and given a positive charge. All of you have my number, yes or no? Please tell me. Is there anyone who don't have my number? Okay, all of you have my number. Okay, Abhiya, you don't have. Wait a second, Abhiya.
So the positive charge will be on CH3 or CH2, sir, in the second one?
Acha, see, what is the concept here? The concept is the number of protons and the number of electrons were same initially. But once you break the bond, this bond is made up of 2 electrons. Yes or no, Sahel? Right?
Yes, sir.
One bond is made of 2 electrons. Okay. And also, sharing of electrons takes place whenever you have a covalent bond. So one of these electrons will be from carbon, the other electron will be from halogen, right?
Right.
Now, once you remove this, what happens? X gets a negative charge. That means X is taking both of the electrons. Okay, X is taking both of the electrons, right?
Right.
Now, if X is taking both of the electrons, now this carbon, it has one electron less. Now, since this carbon is 1 electron less, it will get a positive charge because the number of proton is more and the number of electrons is only 1 less than the number of protons now. Is that clear? Who will get the charge? The carbon which is breaking the
CH2.
bond. The carbon which is breaking
Okay.
the bond will get a charge.
Got it.
Okay, I have got from Adriel. Yes, Adriel, very good, correct. Don't have to do anything else. Remove the bond, remove the X, and add and put a positive charge on the carbon atom from where you have removed the X and the bond. Waiting for other answers. Waiting for Abdurrahman, Abia, Fahad, and Sahal. Abia, I have got your answer. Okay, first one is correct, second one is correct. Third one, fine. Fourth one is fine. Very good. Waiting for others. Abdurrahman, please send it fast now. What happened? Achha, I've got some chats here. No need to write X negative. Adriel, I have replied to your answers now. Abdurrahman, I got yours. Abdurrahman, in the last, okay, you forgot all the bonds. No need to, don't forget all the bonds. Just the bond with X. You'll have like this CH3, CH2, and then positive. Got it, Abdurrahman?
Yes, sir.
Don't remove all the bonds, only the bond that is with X, because this is going to. So this is one of the most essential skill that you have to develop: formation of carbocation. How to form carbocations. Okay. Abdurrahman got yours. Okay. Oh, how are you writing? Yes, Sahel, I have got yours. Fahad? Sahel, your number ends with 7467, right? Yes, Sahel?
Yes, sir.
Your number ends with 7467.
Yeah, that's my number, but I'm using my
Yeah.
mom's number right now because I'm in India. So I'm sending you from my mom's WhatsApp.
Okay, fine.
Yeah.
Sure. I should save this number as of now at least, right?
Yeah.
Fine. Fahad, I have not received your answers. Fahad, are you there?
Yes, sir. Doing so.
It is just drawing. I don't know what is taking you so much time. Just need to draw the same thing, except the X and the bond and add a positive charge. Fahad Aziz, can you please send me whatever you have done?
Yes, sending.
Yes, Fahad, I've got yours. Very good. Everything is fine. Very good. This will be CS3, CH, CS3 and a positive charge. This will be CS3, carbon, CS3, CS3 and a positive charge. Some of you may have written positive charge somewhere here like this. That is also fine. It just needs to be near to this carbon atom. Okay. Generally, the textbook they show it like this. Now, all of you know that this carbocation will be electron deficient. It has one electron less. And the methyl groups, what they do, they act as an electron donating group. So these methyl group, they will be giving it some of the electron. This methyl group will also be giving the electrons like this. Now, since this methyl is what, it is 3 degree, it will be giving electrons from 3 different methyl groups. This will be 2 degree, this will be 1 degree, and this will be 0 degree. Now, since this carbocation is lowering the charge, whenever there is a lowering of charge or a distribution of charge, what will happen? There will be stability. So this was electron deficient and it is getting the electrons. So it is getting happy, and that is why more stable. So 3 degrees more stable than 2 degree, followed by 1 degree, and then followed by 0 degree. So this will be the rate of Sn1. This will be the order of reactivity of Sn1. If I talk about the substrate here, then this will be fastest towards Sn1, followed by 2 degree, and then followed by 1 degree, and at last you will have the 0 degree methyl. So please write the arrows. Let me know when you are done. How many of you understand 0 degree, 1 degree, 2 degree, and 3 degree? Raise your hand. Oh, sorry, wait a second. Don't. Raise your hand if you know it. What is 0 degree, 1 degree, 2 degree, 3 degree? Please raise your hand. Sahel, you know. Abdur Rahman, आपको नहीं पता क्या? Abia. Okay. Adriel, are you here? No. Adriel, आपको नहीं पता 0 degree, 1 degree. आप मार खाइएगा क्या? हाँ, not connected to any carbon atom. Yeah, correct. हाँ. Okay, 0 degree आपको नहीं पता था. Okay, Fahad, can you have me please? Yes or no? Tell me. Are you there?
Yes, sir.
Okay, fine. So look, this carbon which is connected to halogen, it is known as alpha carbon. Okay, what is alpha carbon? Tell me, Fahad, what is alpha carbon?
The carbon which is connected to X.
What is X? X is
Highlight.
Halogen. Okay, it
Halogen,
is right. No,
yeah.
it is halogen. Oh, yeah, it is halogen. So this is alpha carbon. Okay, this carbon is connected to how many other carbons? Tell me. This carbon is connected to how many other carbons?
In 2 degree,
In 2 degree in the structure.
it's connected to 3 carbons.
Okay, so let me tell me. This carbon is there. It is connected to one carbon, 2 carbon. Where is the third carbon?
No, sorry, 2 carbons.
2 carbon. What about here? It is connected to how many carbons?
Now this one is connected to 3 carbons.
Okay. What about this? Here alpha carbon is connected to how many carbons?
1.
So now you understand what is 1 degree, 2 degree, 3 degree? Yes or no? Tell me.
Yes, sir.
Okay, fine. Chaliye. Since all of you have written, write a small question. Arrange the following. In increasing order. Of Sn1. Okay. How many of you are comfortable with this type of structure, bond line structure? Please raise your hand. How many of you are comfortable with bond line structure? Raise your hand. Okay, Abdul Rahman. No one else. Okay. So I will also draw, please draw this bond line structure, and then with me, what you will draw the expanded structure. So this is what? Whatever the dots are, starts here. This has 4 carbon atoms. This also has 4 carbon atoms. And this also has 4 carbon atoms. Okay. Now, please remember, you will not write that this is a carbon atom. It is not a carbon atom. It is a bond which is bonded to bromine. Okay. So whenever, if you have any particular atom here, which is given explicitly, it is shown, that means it is just that atom. There is no carbon atom there. Okay. It is connected to this carbon atom. So whatever the blue parts are, there are 4 carbon atoms here. So you write CH3, CH2, CH2, CH2Br. Now here what you write, CH3 followed by CH2 followed by CH, Br and CH3. Here you have CH3 which is connected to carbon, which is connected to CH3, which is connected to CH3 and a Br. Okay. Now please look here. This carbon has 2 bonds. So the number of hydrogen will be 4 minus 2. That is equal to 2. So see, 2 hydrogens. Here also 2 bonds, 2 hydrogen. Now if you look at this carbon atom, how many bonds are there? Fahad, tell me. This green carbon atom has how many bonds?
2.
नहीं देख के बताइए ना, गिन के बताइए, ऐसे कैसे आप, मतलब how many bonds can you see? How many lines? Fahad?
1 line.
1 line only. How many bonds can you see, Fahad? आपने ये structures देखे नहीं है क्या? हाँ. Okay, fine. Now you tell me. Now number of hydrogen will be 4 minus 3, which is equal to 1. Okay. So see, this carbon has only 1 hydrogen. Achha.
Okay.
I have given you some recordings. Yes or no, Fahad? Tell me to watch. Yes,
No,
Fahad,
I have to watch.
I have given you, but right.
You haven't sent me.
I haven't sent you.
Yes.
Okay, so there is one lecture you have to watch before the next one. Okay.
Okay.
Assalamu alaikum, Muhammad Umar. How are you?
Walaikum salam, 75.
Eid Mubarak.
Eid Mubarak.
Okay. What happened? Quite late?
I was outside.
Sorry?
I was outside.
You're outside. Still celebrating Eid.
Yeah, you can say that.
Okay. So Fahad, please watch this lecture that I have sent you right now. Okay. Okay, fine. Chaliye. So please write what is A, B, C, 1 degree, 2 degree, 3 degree. And then you have to arrange them in the increasing order of Sn1. Send your answers in chat. No, you click a photo and send me. What is 1 degree, 2 degree, 3 degree? A क्या होगा? 1 degree होगा, 2 degree होगा, 3 degree होगा, क्या होगा? Identify the alpha carbon, and then you will tell me. Yeah, WhatsApp. I want to also see how you have drawn these figures, right? So if there is any mistake, then I can correct you guys also. I just want to see the pictures, the structures. And Abhiya, did you watch the lectures, the previous ones, or haloalkane, halorine at least? No. Only one. Abdurrahman, I have received your answers. Correct. Very good, Abdurrahman. Very good. But not now, Muhammad Umar. Okay. Up at the end of the class, maybe. Very good, Abhiya. Now you can also which of these will be fastest, then which one. You can also write the order, yes or no, Abhiya.
Sorry, sir, can you repeat? I was not able to hear.
I'm asking, since you have identified which is 1 degree, 2 degree, and 3 degree, you can also write them in the increasing order. Correct?
Okay. Yes, sir.
You can write now which will be fastest. Okay, waiting for others. Okay, I have received someone else's. I have received Adriel. Very good, Adriel. Correct. Very good. Waiting for Sahel and Fahad. Sahel and Fahad. Fahad, send me whatever you have done. Muhammad Umar, what happened? You're asking, sir. I have seen yours. I'm saying, not right now. Acha, आप answer दे रहे हैं. Very good, correct, Muhammad Umar. Sahel and Fahad, please send it fast now, whatever you have done. And Abhiya, once you are done with the answers, now, please send it to me.
Okay.
Very good, Fahad. You have sent me one answer. See, very good. आ रहा है फहद आपको अब, है ना? Yes, Fahad, a bit more comfortable with organic chemistry. Okay, fine, good. Acha, since you have identified 1 degree, 2 degree, and 3 degree, similarly you can also write them in the increasing order. Correct? Which one will be the fastest? Then which one? Then which one? Fahad, yes or no? Sahal, I'm waiting for you. Yes, Fahad, sorry. Can you repeat that? Sahal, are you there? Seems you're not here. हाँ, very good, Fahad. Correct. अभी आपने कर लिया compare? Yes, Abhiya.
Yes,
Okay, fine.
sir.
I have received your answers. Very good, Abhiya. Very good. Fine. So all of you have given the correct answers. Now what we can do, we can move on to the reactivity of Sn2. Please write next one. Reactivity of Sn2. You have seen the reactivity of Sn1. Second is reactivity of Sn2. Now in reactivity of Sn2, you'll write it depends on the nature of bulky group. अरे यार कौन है? Just a second. No? Sorry. Okay. It depends on the nature of. Okay, fine. No problem, sir. It depends on the nature of bulky group attached to the alpha carbon. You all know what is alpha carbon? The alpha carbon is the carbon that is that is alpha carbon is the carbon
That has the halide.
that has the halogen atom. Yeah, correct. Bonded to halogen atom. Okay. Please write. Next point. As the number of alkyl group, as the number of alkyl groups increase on alpha carbon, the number of alkyl groups increase on alpha carbon, it will hinder the mean act as a barrier. It will hinder the incoming nucleophile. It will hinder the incoming nucleophile because we said that it attacks on the back side, because in the front side we already have a halogen atom. Incoming nucleophile. What will write? Due to which the reactivity of Sn2 decreases. Okay, so you can see if you have carbon which is bonded to only hydrogens, so you have 3 hydrogen atoms like this, so these are very small. Okay, so it's CH3x, CH3, CH2x, CH3, CH, CH3x, and at the end you can have CH3 carbon bonded to 3 CH3 groups and a halogen atom. So as you can see, if the nucleophile, and also please remember, whenever we write CS3, it means what? We have 3 hydrogens also. This carbon has 3 hydrogen atoms also, like this. Now you can see there is no place for the nucleophile to come and attack from the backside, because we have CS3 here also, CS3 here also. And that is why the 3-degree carbocation, 3-degree alkyl halide will be not showing the Sn2. It will not show nucleophilic substitution through the Sn2 mechanism. This is 3-degree, 2-degree, 1-degree, and 0-degree. So 0-degree will be fastest. It will be the most reactive towards Sn2, followed by 1-degree, followed by 2-degree, and 3-degree. Okay, so please write this down. Done, everyone? Yes or no? Please tell me. Done or still writing? Done, I guess. Okay. Write a very important note here. Please write. Alpha unsaturation. Alpha unsaturation decreases the reactivity of both Sn1 and Sn2, of both Sn1 and Sn2. What is alpha unsaturation? We know what is alpha carbon. What is the alpha carbon? Alpha carbon is the carbon which is attached to the halogen atom. Now, when this same carbon, it has a double bond like this with another carbon atom, what will happen? It is saying that this type of system, it will decrease the reactivity of Sn1 and Sn2. That means it will be not showing the nucleophilic substitution reaction. What is happening here? Now see, if I talk about the Sn1, let us say that it goes through Sn1. If it want to go to through Sn1, what will happen? It will form carbocation, C double bond C, and then X. So if X will leave, you will have carbon with a double bond carbon, and there will be a positive charge. Now this is unstable. Why? Because this carbon atom is attached to this carbon, which is sp2. And sp2, it has higher electronegativity. So this sp2 will be doing what? It will increasing the positive charge here. Okay, so this particular carbocation is unstable. And since this is unstable, what will happen? It will not show. Therefore, doesn't show Sn1. Okay. Now what about Sn2? It can go through Sn2? No. Why? Because when we have C double bond C and then X, we have a nucleophile with high electron density. Okay, please listen, don't write. Now, once the nucleophile will come and attack on this carbon atom, it will see that this carbon atom, it is surrounded by this pi electron cloud. It is having a pi bond. Now, this pi bond is also an electron source. It is electron rich. It has a negative charge. This nucleophile is also electron rich. That is why what will happen? There will be a repulsion between what? Repulsion between the pi electrons and nucleophile. And that is why what will happen? The nucleophile will not be able to attack on this particular carbon atom. And also a second general reason why it cannot do neither Sn1 nor Sn2 is that since what has happened? Since this CX bond has partial double bond character, due to resonance, it is very difficult to break. It is very difficult to break. Okay, it is very difficult to break. Fine. So what is the resonance? So you have C double bond C with X. X has lone pair electrons. This lone pair can do resonance like this. Single bond C double bond X, and the resonance hybrid will be both of these bonds will be having delta negative here also. This will be delta positive. This will be delta negative. Okay, so since here it has partial double bond character, it will be tough to break. Write this down. Let me know when you are done. Sure, Adriel. Wait a second. I can zoom out. Yeah, partial double bond character is there. That is why it is difficult to break. Done, everyone? Yes or no? Please tell me. Done, guys? Okay, seems all of you are done. Now, write a question. If you're asked to compare the reactivity of CH3, CH2, X versus CH2 double bond, CH bonded to halogen atom. So as you can see, this is the alpha carbon, and there is an alpha unsaturation. That is why what is going to happen? This will be slower and this will be faster. Okay, so this normal haloalkane will be faster. Also, that is why if you have something like this, versus you have benzene ring attached to halogen atom. So look at this particular carbon atom here. This carbon atom has a pi bond, right? This is the pi bond here. Okay, this is the pi bond here. This is also an example of alpha unsaturation. Okay, that is why the cyclohexane with the halogen atom will be faster. For both Sn, okay. This will be for, let us say, Sn1, Sn2 probably, and this will be for Sn1. Whatever be the case, alpha unsaturation will always decrease the reactivity. Okay, it will always decrease the reactivity. Okay, after this you will write nature of leaving group. Nature of leaving group. You write here. What should we write? So whenever you have a leaving group, whenever you have to compare the leaving group, what you have to do? You have to see the overall charge bearing capacity. If it can easily bear the charge, then what's going to happen? It is going to show faster Sn1 and Sn2. It is going to show faster Sn1 and Sn2. It is right. The rate of Sn depends on the stability of halide ion, that is the leaving group. That is the leaving group. Okay. So if I look at the halide ions, we have F negative, Cl negative, Br negative, and I negative. On the basis of what? On the basis of charge, I can say that all of them have same charge, so they will be equally unstable. But when the charge is distributed over a very large area, that is why I negative will be the most stable, followed by Br negative, followed by Cl negative. This is the order of stability. Okay. If I compare the rate of Sn, then a molecule with Rf will be the slowest, followed by Rcl. Then RBr will be faster than RCl, and also then Ri will be fastest. There is another reason for this. The another reason is, since carbon iodine bond is long, it is easy to break. Okay, so there are two things. First thing is that I negative is more stable, that is it can easily break, and also Ci bond is what? It is long, that is why it is easy to break. This is the leaving group. This is the leaving group. So if you have the substrate, it is same. If the R is same, if the alkyl group is same, then you will compare what? You will compare the leaving groups. You will compare the halogen atoms. Write this down, then we'll do some question and then be done with this class. Done everyone? Yes or no? Please tell me. Is there anyone who's still writing? No. Done. Okay. Right. Compare the following. As indicated. The first one. Okay, so A and B I'm writing. Wait a second. So here you have all the A. Now you have to say which is one is faster, A or B. Okay, you have to compare here Sn1. Mhm. So please remember a few things. If you have Sn1, then what you will look at? You will look at the first you will look what is different. Okay. So if the alkyl is different, and it is given Sn1, then you will look at the order will be what? 0 degrees least, followed by 1 degree, followed by 2 degree, and followed by 3 degree. Okay. Then if you have Sn2 here, then it will be 0 degree fastest, 1 degree, 2 degree, and then 3 degree. Now, if the Lg is different, then what will be the order? The order will be, you have to look at Rf will be slowest, followed by Cl, Rbr, Ri. Okay. So first of all, you have to see what is different. The alkyl group is different or the leaving group is different. Okay. And also one more thing. If you see a pi bond, then you will remember alpha and saturation. Decreases the rate of both Sn1 and Sn2. So this is the crux that is also there in your notebook. Okay. Apply this, send the answers on my WhatsApp. 5 question I'm giving you, like I have started writing very early. So 3 more minutes. After 3 minutes, you will send me the photos. Okay. Whatever you have done till now. 2 more minutes. You have to just give an arrow. This is more faster, this is more faster, which is faster, like this. Nothing else. Okay.
Arrow means like I didn't get it.
Greater than sign, lesser than sign is
Okay.
there, na?
Achha, okay, that. Okay.
That. Send me answers, no? Whatever you have done. Send me the answers, whatever you have done. Which one, Fahad? Tell me. Turn your mic on, Fahad. Turn your mic on. Fahad. जी बताइए.
The first one.
Fourth one. First one. Okay, fine. What is different? Is the alkyl group different or the leaving group is different? Tell me. Fahad, tell me. Is the halogen leaving group का मतलब halogen होता है, right?
Yeah.
So tell me, halogen is different या alkyl group is different? Alkyl group का मतलब जो भी कार्बन वाले atoms है हमारे पास.
Leaving group is different.
Leaving group is different. तो क्या होगा order देखिए बताइए. Tell me which one is faster. कौन सा faster होगा? Cl वाला या I वाला? Tell me.
I will be faster.
हो गया? ठीक है. Next वाला बोलिए. What is different here? Leaving group same है या different है? The leaving group is same or different here?
Same. It is same.
Same. Alkyl group is different? Yes or no?
Yes.
So Sn1 और Sn2 क्या है? Sn1 और Sn2 what is there? What is there? ये हम पूछ रहे हैं ना, बताइए क्या है? Sn1 है Sn2? हाँ?
Sn1.
Sn1. Okay. Now what you have to do? You have to identify the alpha carbon, which is here. The alpha carbon here. So what is the degree? Write the degree. कितना डिग्री कार्बन है यहाँ पे, कितना डिग्री कार्बन यहाँ पे. Count the bonds with your hands. Don't look and count. Okay. Count your bond. Count the bonds. Number of bonds with your hand. Okay. कितने carbons attached है? So tell me, A is attached with how many carbons? A is attached with how many carbons?
1.
Look again. How many A is attached with how many carbons? This carbon atom. This carbon atom is attached with how many carbon atoms?
Okay. 3, 3.
Look again, how many carbon atoms? How many carbon atoms? Look again. Fahad, keep your pen here. Can you see this? Wait a second. Fahad, are you there?
Yes, sir.
Keep your pen here. Okay. It has 3 things, 1, 2, and something down. So it is, this bond is connected to what? Tell me. This bond is connected to carbon or
2
something else?
bonds.
2 bonds. Okay. So this will be what degree? 1 degree, 2 degree, 3 degree. What? Tell me. 1 degree, 2 degree, 3 degree. A will be 1 degree, 2 degree. Arey,
2 degree.
And this one, B is
2 degree.
B is फिर से देख के बताइए.
3 is 3 degree.
हाँ, this is 2 degree, this is 3 degree. कौन सा faster होगा SN1 के लिए? What will be faster for SN1? Please send me your answers. I have received answers from Sahal. I've received an answer from Adriel and Abdul Rahman. Abia, please send your answers. Abia, whatever you have done, please send it. Which will be faster, Fahad? I'm asking ना. कौन सा faster होता है SN1 में? 2 degree या 3 degree? Tell me. This is 2 degree. This is 3 degree. Which is faster than SN1?
3 degrees faster.
Easy है? Yes or not, Ronnie?
Yes, sir.
क्या देखिए, आपको प्रॉब्लम इसमें नहीं आएगा कभी भी. You will have problem in counting. Counting का प्रॉब्लम आएगा ना. You had problems in counting the number of carbon atoms, नहीं? So उस पे आप फोकस कीजिए, ठीक है? अभी SN1 आप ये बोलिएगा कि SN1 में और SN2 में हमको प्रॉब्लम है. You don't have a problem in SN1 and SN2. अगर आपको ये पता चल जाता है कि 2 डिग्री 3 डिग्री है तो आप बता देते हो. अगर आपको ये पता चल जाता है कि नंबर ऑफ कार्बन कितने हैं तब भी आप बता देते हो कि 2 डिग्री 3 डिग्री. तो आपको 2 डिग्री 3 डिग्री पहचानने में भी दिक्कत नहीं. आपको क्या दिक्कत है? इन काउंटिंग द नंबर ऑफ कार्बन एटम्स. सो यू विल फोकस देयर, ठीक है? नाउ दिस इज आल्सो फॉर एवरीवन हाउ यू हैव टू पुट फॉरवर्ड योर डाउट्स. ये रेट आप ऐसे, हाँ क्या होता है अक्सर बच्चे, रेट नहीं आ रहा सर, SN1 SN2 नहीं आ रहा. नहीं, आपको SN1 SN2 आ रहा है, आपको काउंट करने नहीं आ रहा नंबर ऑफ कार्बन एटम्स. दैट इज योर प्रॉब्लम. सो दिस इज हाउ यू फोकस एंड पिन पॉइंट the problems that you are having the doubts that you are having. ठीक है? Okay, Abdul Rahman, I have received further more answers. अच्छा, Abdul Rahman ने सब चेंज कर रहे हैं आंसर्स अब. Okay, I will be putting up the answers now. So look here. Now here, if you see, this is alpha carbon. Once you see that the leaving groups are same, just focus on the alpha carbon. This is also alpha carbon. Now, if I look at this alpha carbon, it is having a double bond. That is why this will be alpha unsaturation. If alpha unsaturation is there, what will happen? It will lower it will decrease the rate of both SN1 or SN2. So we don't have to look whether it is SN1 or SN2. The leaving groups are same, and this will be faster because it has alpha unsaturation. If I look here, this will be faster because again this is having alpha unsaturation. Okay, if I look here, SN2.
If there will be double bond, then it will be unsaturation, right?
No, double bond where? Where is the double bond? On the alpha carbon. On which carbon? पर आपने ये पॉइंट नहीं लिखा है. आपने ये पॉइंट नहीं लिखा है. This one you have written or not? Tell me.
Yes, I have written.
हाँ, so that is the same thing ना. देखिए, same ही चीज था. You focus on this part. C double bond C, and then halogen, right?
Yes.
So also we have done this question also. Now in SN2, the next question is for SN2. Look at the alpha carbons because the halogen is same. When we are looking at the alpha carbon, I can see that this is
Sir,
2 degree. This is 1 degree. हाँ बताइए.
explain the fourth question once again.
Fourth one. What is the alpha carbon is having a double bond, right? Yes or no?
Yes, sir.
And we have shown why it will be slower. Yes or no? नहीं लिखा आपने ये part.
Because of partial double bond.
Sorry, because of
Partial double bond.
Partial double bond repulsion between pi and a nucleophile, both things. है ना? Partial double bond character, the carbocation will be unstable. Yeah, all those reasons. Okay. So this is 2 degree, this is 1 degree. In Sn2, Abhiya, you have made a mistake. I'm very disappointed now. How can you make a mistake here? See, the alpha carbon here is 1 degree because it is connected to only one carbon atom, right? And that is why the rate will be, this will be faster than the B1. Sorry, B will be faster than the A1. Please write this down. All of you got these answers? Yes or no? Please tell me. Is there any doubt?
No, sir.
Okay, so till here you will be asked. Okay, till here you will be asked on the test. So those who are late, you have a subjective test. That means written. Okay, subjective test on Wednesday. The topic will be physical properties. Till today's lecture. Okay, till today's lecture, it will be of 30 marks. Sorry, 30 minutes, not 30 marks, 30 minutes, 10 marks. Also, the next class, it will be from 4 to 5:30, you will have lecture. And from 5:30 to 6, you will be having test. Okay, so this will be the pattern. Please note it down. Okay, so I'll wait a second. Muhammad Umar, you're asking something. I think all of you have done now. Yes or no? Please tell me. Stay if you want, and you can leave if you want. Assalamu alaikum to all of you. Okay, Abdurrahman, Abia, Adriel. If you have doubt, please say. Sahel, I am sending.
Yeah. Okay, sir.
Wait.
Okay.
आप रुक जाइए. आपको भेजना है ना. Muhammad Umar, you're asking something. If anyone has doubt, please stay. Okay.
Sir, can I ask it after writing it?
You have not written it. क्या कर रहे थे आप? हाँ. Structure नहीं बनाया था आपने?
No, sir.
क्यों नहीं बनाया था आपने स्ट्रक्चर? नहीं बनाने देंगे अभी तो हम आपको. आप पूछिए नहीं. ऐसा क्यों? इतनी देर से स्ट्रक्चर बना हुआ था ना मोहम्मद उमर. So what were you doing? Tell me. हाँ.
So I was just understanding and trying to.
नहीं, जब तक आप पेन नहीं चलाएंगे दिमाग नहीं चलेगा आपका. Can you please keep this as a slogan? Okay. So move your pen, then only your mind will work. Okay. So you draw as soon as I have given the questions, you draw them, then only you will understand, na? ठीक है, आपको नहीं बनाने मिलेगा. You will fetch the recording and then you will make it. Okay, punishment. And then you will remember also. And you can also write if you remember the questions. Now, what was your question, by the way? You're asking about
The rate law.
Rate law. मोहम्मद उमर को जितना punishment मिलता है उतना शायद ही किसी को मिलता होगा. Right, मोहम्मद उमर?
Yes, sir.
हाँ. But याद रहेंगी चीजें आपको. Okay. So rate law for Sn1.
And also the mechanism.
Mechanism also. So K into Rx only, right? For Sn1. This is the rate, na? You want to understand this, right?
Yeah.
Okay. So Sn can happen in 2 ways. So in Sn1, it happens in 2 steps. The first step is cleavage of CX bond. So you have CX bond, it breaks and you get C positive and X negative, right? And then the second step, what happens? The attack of nucleophile or the formation of CNU bond. So you have carbon, which is positive, and then there will be a nucleophile. It will attack on this carbon with its lone pair, and you will get a carbon nucleophile bond like this.
Sir, I'm sorry to interrupt, but would there be any question like what is the strongest nucleophile and stuff?
CBSE generally no.
Okay.
Generally no. Okay, strongest nucleophile. Strongest nucleophile, you can say that the nucleophile which is having negative charge, pure negative charge, and it is also lower electronegativity. So nucleophile is strong if it can donate the electron, right? If it can easily donate the electron, then it is what? It is a good nucleophile. So if you want to ask about the donation capacity, it depends on two things: charge. So if it is having negative charge, then it is what? It is a good nucleophile. And also if it is having less electronegativity. If it is having less electronegativity, that means it can donate easily. It will not have problem in donation. So both of these options can be there. Okay. So the best nucleophile will be, you know what, CH3 negative. A carbon with a negative charge, and it is very, 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 very unstable. As soon as you will put this, it will act as a very great nucleophile. Okay. CH3 negative. If you are able to, I mean, you can make CH3. We will see in this chapter only how. Okay. Now, there are two steps here. And do you know that the slowest step is the rate determining step, or you have problem understanding this? Slowest step is RDS.
I was confused. What is RDS?
Rate determining step. That means the rate is determined by this step, the first step. Don't understand this? Okay. So generally, I ask this question.
It actually depends on how fast the cleavage occurs.
Yeah, exactly. Because the cleavage is the barrier here, right? It is going to be slow, and it is also going to be, you can say, reversible in nature, because once it breaks, this X also can attack. The nucleophile is also having some lone pair and high electron density. X negative is also having high electron density. That is what can happen. It can be in equilibrium, like not in equilibrium exactly, but it will be reversible. Okay. So this arrow, it does not mean equilibrium. Okay. It means it is reversible in nature. And that is why it will be slow. Okay. That is why it is really slow. तो आपको ये लग रहा होगा, like after this step has to happen, right? So why is this rate not dependent on this step? You have that problem?
Yeah, a bit.
A bit, huh? So actually, as an, you will have, for example, if I take just 1 mole, so you will have how many molecules? You will have 10 to the power
23.
How much? 23 molecules. Now, if any one of them has been C positive, the nucleophile will not wait for each and every one. There will be many nucleophiles, right? So the nucleophile will not wait for the other carbon atoms to get C positive. It will attack here, right? It will start attacking here. Are you getting my point?
Yes, sir.
So it doesn't mean that all the haloalkene, they are waiting to get converted into C positive, and then they are going to form the CNU bond. And in a way, you can say that both of these things, that means CX, for it is happening in one molecule, and this step is happening in some other molecule. Yes or no? Can I say that?
Yeah.
So both of these things are happening simultaneously in different molecules, correct?
Yeah.
Now, when you have something like this, the rate will depend on the slowest step. I will tell you how. If you are going to dry, this is my favorite example. Those who were present here, they will be very much bored now. If you have a t-shirt, shirt, and jeans, and you want to dry it out, okay? These are normal things. There's no exceptions here, okay? These are normal things. Normal t-shirt, normal shirt, and normal jeans. If you want to dry it out, and you're drying them together, so the drying time, it will depend on jeans, yes or no? Because it is going to take more time, because it is going to be slow. Yes or no?
Yes, sir.
Now, since these things are happening simultaneously, even though if you have put t-shirt first, then you have put the shirt, then you have put the jeans, okay? Now, it is not that you are waiting. You're not waiting for the t-shirt to dry. You're not waiting for the shirt to dry. But this is something that you have done in sequence. Still, the time taken will depend on the jeans. Still, the time taken will depend on. That is why it depends on the cleavage of CX bond. Is that understood?
Yeah, understood, sir.
Okay. Anything else here?
No. Understood.
No? Fine. The stereochemistry, that will be, I will be dealing with stereochemistry very later in the chapter, okay, at the end. Fine. If you have doubts in stereochemistry of this Sn1, Sn2. Okay. चलिए screenshot ले लीजिए साहब. Even though my name is Salim. Sorry?
Could you also explain the same for Sn2 if possible?
I can explain. What do you have doubt? Tell me for Sn2.
The same thing, rate.
Rate equation. Okay, so in Sn2 there are this thing is happening simultaneously. So you have nucleophile, and then you have the CX bond. This nucleophile is attacking the CX bond, and simultaneously this X is leaving, right? So you will have nucleophile, carbon plus X negative,